Okay, so we are now recording. My mic should be working. Okay, so now I need to go back out to my hover cam. All right, good morning. It is Saturday, May 15th, just after 8 o'clock. This is our Saturday of Success. Woohoo! Snacks for all. This is our geometry session. And this session is going to be running from about 8 to 9:30. And there are some other sessions in the building. We are in room 213. I'm Mr. Queen, and we're going to be doing geometry. As I understand it, the actual SOL is on June 2nd. So that's just over 2 weeks away. All right. So first thing I want to go over real quick is not Winger, but our Desmos calculator. First of all, I want to make sure everybody is using it. And if I'm not showing what I'm saying I'm talking about, just let me know. Sometimes I forget. Okay. But I do have the Desmos calculator up there. I want to make sure that everybody's using it because I think they are providing the physical calculators as well, but those are being phased out. And the Desmos just makes things so much easier. In any event, you know how if you get your keyboard, make sure you have that handy, you know where everything is. All right. So just showing around, we got our X, Y buttons, we got our parentheses, open and close, which you should be using for substitution and all kinds of things to keep it organized. There's your squared squared button, A squared. If you need to do something other, exponent other than a squared, there's that A to the B. That B you can punch in any number, including a 2 if you want. Down here we got that absolute value. Some people forget about that. That's more for algebra, not so much geometry, but just pointing it out anyway. We got our comma, which will come in handy. We got our less than, greater than symbols or equal tos. We got our other switch for keyboard here, which might come in handy later on. I'll show you something with that. We got our square root. We got our pi symbol. And again, unless the directions specifically tell you to use 3.14, you should be using the pi symbol. You know that, right? For some reason, there's some problems that they felt the need to say use 3.14. And then you'll have those problems where it says leave it in terms of pi, meaning that you don't actually calculate pi. You just make sure you add it when you're done calculating. Like your answer will be 5 pi, and you can see that in your answer choices. Okay. And then, of course, we got all our regular number buttons with functions and equal signs. And then, of course, over here, the actual functions that we need specifically for when we get to triangles, right triangles, we got our sine, cosine, tangent. For our inverse trig, we got our sine -1 cosine, and tangent -1. So make sure you know where these things are. These you won't really need to worry so much about. This is more algebra, so I'm just covering bases here. But yeah, make sure you definitely know about your trig functions, these 6 right here. Okay. So as far as just a quick review of Desmos graphing calculator, and again, make sure it's Desmos graphing calculator. Those are the keys. Now, there's one other thing I want to make sure everybody does. Hopefully, Mrs. Holmes or whoever you have has told you the first thing you do when you sit down with your calculator. Do you remember what that is? I don't care if it's the physical TI-84 or whatever, or this thing. You got to do it. You got to change something. Okay, so
I remember we had to change something.
Okay, I'll show you right now. It's over here on the wrench. That's the graph settings. Click that wrench. Make sure you patch your calculator in degrees. By default, it's going to be in radians. You need to make sure you have it in degrees. Now, this won't affect everything you deal with, but where you will have problems is when you get to the trig, because you'll get some answers that will not be working or they won't be correct, and they'll be pretty far off, okay? And you may not realize that unless you have multiple choice answers that don't match what you have. So make sure that you put it in degrees, okay? I just do that first thing. It's not going to hurt anything else, so you might as well change it now, okay? All right, so that was the calculator. Any questions about that? Okay, so next we're coming over back to the hover cam, and we're going to take a quick little tour of the formula sheet. Now, I'm going to zoom in more. Let me get full screen here. And Let me see if this is going to work, because sometimes this doesn't do exactly what I hope it does. Now, I don't know that they'll give you a physical sheet in the SOL, but there will be a PDF at the very least attached inside the test. You've probably seen that in Mastery Connect, is that right?
Yeah.
Okay. I like a physical one. I wish they'd give physical ones, but I don't know that they're doing that.
I have a question.
Yes.
So I know that there's 2 sessions up here, but will I be able to go to 3 different tests?
That's up to you.
Oh,
There are 2 actual sessions. You can go back and forth for what you want. If you feel like you get enough out of this, you're welcome to leave. I'm going to keep going though, because I'm making a video for anybody to watch. Okay. So it's just whatever you feel is needs best for you. Okay. Now my graph sheet or my formula sheet probably looks a little different because I marked mine up. All right. That's what's called a brain dump. But even if you don't have a physical formula sheet, make sure you have scratch paper and you write stuff down, the kind of things that you don't get on the formula sheet. Like for instance, hope I didn't label these, but hopefully you know that's the distance formula. D equals all that under the square root radical there. MP for midpoint formula, you got to solve the average of the x's, average of the y's to get a midpoint. Here's my slope formula. I got lots of different versions in here. Rise over run, y2 minus y1 over x2 minus x1. It's also known as K for the constant. That was more a thing in algebra, but I put it anyway. And then you got the point slope formula, which all these things you should use at some point. Got slope intercept form, standard form. Right up top, I also said for a reminder for myself, put my calculator in degrees, and I'm gonna keep hammering away at that because I would hate for y'all to miss 4 or 5 trig problems because it wasn't in degrees. You know what I mean? And then all this other stuff, for the most part, is just things that I labeled because they don't label it for you. Like obviously this is a triangle, but I wrote triangle. Rectangle, square is not on here, though it is on the algebra sheet, but a square is a rectangle, so this still works. However, there's some shortcuts for the square. So instead of this times that plus this and this, for perimeter, you can just add up the 4 sides or multiply them 4 times sides. And then area, length times width. Side squared, that's a side times side. It's still length times width, but it's a slight little shortcut. All right. Parallelogram and trapezoids, just making sure everybody understands that H with the dotted line inside there, that's the height. And when it comes to the parallel lines, make sure you understand those top and bottom, those are referred to as the bases that are parallel, and those are right angles. Same thing with our trapezoid. The top and bottom, those are our bases and they're parallel, okay? Regular hexagons, if they give you a problem like that, just follow the answers. You got the perimeter and all that good stuff in there. Circles, there's everything you need to know. Now, I added something that I think is real handy when you're dealing with sectors, whether it's for area or length. It's the same formula because distance is circumference, area is area. But the way I like to write it is piece of pie times circumference. When I say piece of pie, that means the length of that sector, you know what I mean? Or the measurement in degrees of that sector over 360, piece of pie. Does that make sense? That's how I say it. And then that's times whatever else is circumference or area. Prisms, you know, this can be a lot of different shapes. This particular one's a triangular prism. Just reminding that H is the height of the prism connecting the top and bottom base. The big B, that's the area of the bases, and that shape or that area is whatever the shape is. Okay, that could be anything else on this sheet. Y'all know that, right? Okay, so just keep those things in mind. Lateral area, that's basically the area around it minus the bases. And then you got your surface area. Notice it's lateral area, but then they throw the bases back in there. That's the only difference between those two things. Rectangular prism has its own little formulas there. Just follow it along. Length, width, height, and so on and so on. Cylinders, okay, has its top and bottom base, which are circles. Then they got a height connecting it. Spheres, just make sure you have your radius correct. The most common mistake people are going to make on problems, they're going to give you diameter and you use that instead of radius. Make sure you follow along with those. Cones and pyramids, they have a new thing in there. They have a height, which is a right angle from the bottom base going straight up in both cases. There's also that little curly QL going at the slant. That's called the slant height, okay? Cones and pyramids have a slant height, so don't confuse slant height with regular height, all right? And again, both of these have a base. The cone is always a circle. The pyramid, it just depends on what shape they give you. It could be a square, rectangular, it could be, it could be another triangle. It just depends. It has big B, that's the area of the base, whatever that shape is, okay? All right, any questions about that? Here's the thing that drives me nuts. People forget there's a side 2 to this, all right? So you got your right triangles and circles over here again. Right triangles, there's your Pythagorean theorem already wrote out for you, right? A squared plus B squared equals C squared, that's Pythagorean. Right here, here's your SOHCAHTOA, here's your trig. You see it? SOHCAHTOA. That's for trig and inverse trig. That's how I like to write my SOHCAHTOA. Some people may not do that, and that's okay, but that's how I do mine. In any event, trig is when you're finding that X on the outside, that missing side. Trig, that's when X is on the inside looking for that missing angle, okay? Inverse inside. That's the minuses, on the cosine and all that. Circle, why do they have this here again? Well, here's why. Because that's the equation of a circle. People think they got to memorize it, and it's right here on your formula sheet, okay? You punch that in the calculator on Desmos, it's going to draw a circle, all right? Keep in mind, though, it's using the radius. There's a radius. H and K, they're just special X and Y coordinates. That means that's the center of the circle. That's the only thing special about H and K. Their X and Y values, just getting you a circle. And down here, here's some abbreviations in case you forget. Area, base, all those things. So if you look at the front, you see these letters. Well, here's what they mean right here. And then here's some other information, all right? What does that M/A mean? Well, that's the measure of an angle. All this good stuff that people forget about. So that's why I want to take a tour of the formula sheet real quick. Use it. Make sure you look at it. Use it. You don't have to memorize what's on here. Now, all the stuff I wrote, you got to write that yourself. That's called the brain dump. So anything that's important to you, that's what you write down as soon as you sit down. All right, any questions about that? All right. Okay, here's where we're going over those most missed problems, and I already gave you yours. And remember, we got quite a few to get through. I'm going to try to show you all my tips and tricks, everything in Desmos as much as possible. All right, this one's going to blow your mind. Very first one, what's the length of GH? Well, you can't just take a ruler and do it. It's on a graph, so they gave us some coordinate points if we go look at them, right? That's the first thing we need to do is look at those coordinate points, so let's get them. All right, so starting over here using X, 1, 2, 3, 4. So that's -4, and 1, 2, 3, 4. 1, 2, 3, 4, 5. That's a +5. So there's my G. Now here's my H. 1, 2, 3, 4, 5, 6, 7. So I got a 7 and 1, 2, 3, down 3, -3. So you got to double check those if you want, but bottom line is you got to have your coordinate points. Now, if you do what you were taught, you're going to label these X1, Y1, X2, Y2, and you're going to throw them in the distance formula, right? That's what you've been taught, and that's what you should do. Unless you know how to use your calculator. I'm willing to bet that you have not seen this. I just recently discovered it myself. So watch this. All right, Desmos Graphing has some built-in features to it. Type in the word distance. Oh, I spelled something wrong. Distance. All right. Throw in some parentheses like this. All right, so we got to open and open, and that second open is going to be our G. So that's -4. Put that comma in there, and 5. Close parentheses. Now open. Oops, hold on. I forgot to put my comma here. Now open. All right, this is our H. This is going to be 7, comma, -3. And then close it and close it. Now look what it spit out. Do you see that on your answer choices? Yes, you do. And if you want to take the time to do it manually with the distance formula that you've been taught and then put that in your calculator, you are welcome to. When you're done, you're going to get the exact same answer. You can decide for yourself which one is best for you. Ever since I discovered this, That's what I'm doing. You know what I'm saying? Okay, moving on. All right. Don't get stuck in the numbers of these things. Oops, my full screen go. I may not be hitting this full screen. That full screen is being a hassle. Let me just zoom in. Okay, which line is perpendicular to the line y equals 2x plus 3? Well, you know very well that same slopes are parallel, right? And perpendicular looks like that, which means they have that negative reciprocal, which is flip and switch. You've heard that before, right? The negative reciprocal for the perpendicular lines, you have to flip it and then switch the sign. And if you don't remember all that, you know what perpendicular looks like, right? It's a four-way intersection. They cross at a right angle, right? So here's what we do. We're going to take this y equals 2x plus 3, and we're going to put it in Desmos. Y equals 2x plus 3. And look at that beautiful line. That's a positive sloping line, right? Now, if you look at your calculator and see this line, and then you come back and you look at this sheet, you can eliminate stuff right now, okay? Since that line is a positive slope, there is no way it's going to be A. There is no way it's going to be B, okay? That leaves us with C and D, all right? Now, one of them is more obvious than the other, but if you look at it, I'm pretty sure you can tell which one it is. D is extremely steep, which means it's going to be running like this. That is not going to be a right angle. C is going to be running like this, directly at it. That's going to form a right angle. You know what I'm saying? So we can eliminate D as well, and C will be your answer. Does that make sense? And also, if you want to count slope, you know how to count rise over run, right? You are welcome to do that. Just make sure you use the grid lines. But I'm telling you, if you put this in the calculator and just look at the lines, you can eliminate at least half of them every time. Okay? All right, moving on. All right, which pair of segments must be, oh, let me get back to the hover cam. Which pair of segments must be parallel? Parallel meaning they have the same slope. Okay? Now, I'm looking at my picture, I'm looking at my answers. I'm looking for the best way to do this. Obviously, I have points. Obviously, I can get coordinates, and I can count my slope. But there's a quicker, better way to do this. All right, I'm looking. The only possible things that could be parallel in this graph, it's certainly not going to be these two or these two. It might be these two, and it might be these two. Would you agree? That's awfully close. But let's look at our answers. Let's eliminate first. AB and CD. Those two are pretty clearly not parallel. Would you agree? Eliminate. B is AB and GH. That's down here. That's iffy. That's maybe. I'm not sure. C, CD, and EF. That's these two. Again, I'm not sure. D, EF, this one, and GH. I can clearly see those are not parallel. Do you agree? Okay, so now I just need to figure out which of those two are parallel. All right. Now, this might be a case where you might need to count slope, unless you can clearly see it, okay? Now, I can kind of clearly see it, but I'm trained to do that, but I'm still going to count slope, but I'm going to do it a quick way. All right, you see that I have this one here? This one's hitting every single grid. Can you see that? That means that that's a -1 slope. I know that, okay? This one is also hitting every single grid and intersection. That is also a -1 slope. As far as I'm concerned, I'm done. Is that the right answer? B, AB, and GH. Uh-oh, they didn't like that. Let's figure it out again. Did we do something wrong? Oh, that is not hitting every intersection. I've looked at the wrong thing. I'm sorry. That is not hitting every intersection. It looked like it was, but it missed it. You see that? Now I can still count it. It's no problem. It's no problem. But let's look at this one. All right. Let's see. Count up, rise over run. 1, and then 1, 2, 3, 4. -4. Okay, so we got 1 and -4 here. All right, down here, let's see. 1, and then let's say up 1, 1, 2, 3, 4. There's my grid line. There it is, -4. So I just found these two. All right, so I made a slight mistake over there. I got ahead of myself, so I apologize. So it's clear that it's these two. So we did end up actually counting rise over run. And you know how to do that too, right? Okay. In any event, I'm looking for shortcuts. It's kind of funny. When I wrote this down, I was actually looking at the same one again twice. So sometimes that happens. In any event, that's GH and AB, which means the answer is B. Okay. Line L is shown on the graph below. If another line is drawn perpendicular to the line, what must be its slope? All right, so line L, this is one of those special cases. That means that since that line is going through the y-axis, that means that's y equals something. 1, 2, 3, y equals 3, right? Now, right away, since this is perpendicular, I know that's a flip and switch because that's 3 over 1. What I'm looking for is a flip, okay? Oh, I'm sorry, hold on. That's a 0, let's see, 1, 2, 3, yeah, y equals 3. So that slope equals, slope m equals 0, right? Because it's not sloping, right? So that couldn't possibly be A, B, or C, because if it's C, that's going to be parallel. That leaves me with undefined. And undefined means it's going to be going up straight up and down, right? Which means it's going to be X equals something, okay? And keep in mind, if you throw that slope in the calculator for whatever X equals, okay? So if we look at the slope right here and we count rise over run, let's see, let's just say that's a 4 and then 0, 4 over 0. If you put that in the calculator, 4 over 0, anytime you divide anything by 0, it's going to tell you it's undefined. At least the Desmos calculator will. So our answer is D. Do you understand? And by the way, I did all that when I didn't have to. The second I saw I had a special case, I knew it was going to be the other special case because it's perpendicular, right? All right, so we're done with that one. Moving on, and that was our D. Okay, ooh, I printed these out. Okay, I must have printed out the ones before I saved it or after I saved it. All right, in any event, which line is parallel to the line y equals x plus 7? Again, I know that this y equals x plus 7, the reason it's marked like that is because I know it's going to look like a positive slope, a diagonal slope, okay? We know that, which means immediately it's not going to be C or D because those are my special cases, right? Which leaves me with these. Now, these are not in slope-intercept form, but that's okay. I can convert them to slope-intercept form, or I can put them in Desmos. So let's go look at them. All right, I'm going to put them just as they are. So x minus y equals 5. All right. And then my second one is x plus y equals -2. Now, we got two very different lines here. All right. Now, remember, we want the one that's parallel to y equals x plus 7. And we can put that in here as well if we want. Y equals x plus 7. And you can see the red, that's the one we're comparing it to. So we're looking for the one that's parallel to the red line. And it's the purple line, right? And our purple line is x minus y equals 5. So that's not B, it's not C or D. Our answer is A. Does that make sense? A lot of people get stuck in the conversion process, or they don't convert from standard at all. That said, if you don't want to do that, just throw them in Desmos and compare them. Also, one other thing I want to remind everybody about Desmos is don't erase anything. You see how I have a history of things right here? I leave them because I can always come back and use them again if I need to. That saves me time. So just keep going. You can go on forever creating new lines. Keep your history, all right? All right, next problem. Okay, slope, parallel lines and transversals. if A is parallel to B, A and B parallel, find the value of X. Okay, so this comes back to those relationships. We got corresponding, AI, AE,
Oh, you're not showing that.
and consecutive. Oh, thank you. I told you it was going to happen sooner or later. So we got parallel lines and transversal. We got those 4 relationships that prove parallel lines. 3 of them are congruencies, and 1 of them is supplementary, meaning they add up to 180, right? Remember that part? Okay, so real quick, I got my parallel lines, I got my transversal. I can see these aren't on the inside, they're on the outside. One's on the left, one's on the right. They are alternating and they're exterior. So I know immediately my equation is 7x plus 11 equals 10x minus 43. You with me so far? Every single one of these is going to be set equal to each other except consecutive. Those are going to be set equal to 180. Again, you can work those out by hand, but not me. I'm throwing it in Desmos. So 7x plus 11, and always double check your number. Sometimes I forget. I always double check. Equals 10x minus 43. Okay, and again, you may or may not have done this in class, I don't know. But if I put the whole equation in there, I'm looking for my x variable. It's going to be solved, and it's going to be solved by crossing the x-axis. There it is. So if I click on it, when y equals 0, there's my x value right there. X equals 18. You ever done that before? Now you have another option, okay? Me, I'm not doing anything by hand if I can get away with it. You know what I'm saying? Put it in Desmos. X equals 18. And by the way, if you get anything other than a straight line, that means you did something wrong. Check your numbers, okay? It should be a straight line, which means y equals 0 and your x is that x value, okay? All right, more parallel lines. Okay, so this still comes back to the whole consecutive, corresponding, alternate interior, alternate exterior. We're looking for a pair of lines which are parallel, okay? So that means some things in here got to match. Now, I can kind of eyeball things, and I can kind of see P and R might be parallel, but you can't always rely on the sight. You got to go off the numbers since they gave them to us, right? So if I can kind of ignore that 106 for a minute, okay, I can see that this is below here, and this one, sorry, same side, but it's outside the parallel lines. Officially, that's not one of the methods for getting the congruent lines. But remember, keep in mind that I'm ignoring this. This is a linear pair, right? So 180 minus 72 is 108. So that means this is 108. Well, guess what? So is this. That's on the same side, one's in, one's out, so those are corresponding, right? So that means at the very least, P and R are parallel, all right? And that is going to be, since we only have one answer choice, P and R, there it is right there. That's A. I don't have to go any further. So did that make sense, or did I do that one too fast? Okay. In either event, if you need to figure out all the other ones, just do it. You know, if nothing else, just use the linear pair for every single one of these. Vertical angle, linear pair, vertical angle, linear pair, vertical angle, linear pair. If you don't remember the other stuff, but what you do know is the relationships. 3 of them are going to be congruent, consecutive corresponding, alternate interior, alternate exterior, and the other one, consecutive, is going to be add up to 180, right? So any one of 4 of those will give you parallel lines. Our answers only said one set of parallel lines. We found it real quick. Okay? Any questions? All right, another parallel lines. Okay, this time all we have is numbers here. We don't have measurements. It said which pair of angles represent corresponding. Okay, now I don't like the way this looks. I like the way that looks or that looks. I could redraw it or I could turn it. But remember, corresponding means that things are on the same side, but one's inside, one's outside. That's how I look at it. Okay, so instead of trying to figure it all out, let's just look at our answers. Because that's what we go off of, right? 4 and 5. Is 4 and 5 on the same spot in the same spot? Nope. So it can't be A. B, 6 and 7. They're on the same side, but both are inside. Okay, those are consecutive. Can't be B. 3 and 8. We got 3 and 8. Those are vertical angles. Can't be that. It must be 1 and 3. 1, it's on the same side as 3. One's inside the lines, one's outside. Those are congruent. Those are our corresponding angles. So it's D. You see how I did that? Okay. Okay, I don't understand how this one is missed so much, but it's in here. Okay. This has nothing to do with parallel lines or transversals. What we have is a vertical angle, and vertical angles are congruent. Matter of fact, the equation wrote itself. If I just put an equal sign, there it is. You see it? As a matter of fact, I'm not even going to waste my time writing it again. And I'm going straight to Desmos. Turn off the line, next line. All right, so that's 2x plus 29 equals 9x minus 13. And there it is, got a line right there. And my y is 0, my x is 6, and that is correct. And I always double check, is that the question? Because sometimes you got to plug it in and get a measurement, right? I like underlining, sometimes I forget, but it said get the value of x, and there it is right there. Okay, questions about that one? Good. Okay, a midpoint, you're gonna love this. Oh, let me go back. All right, just like distance formula, I got you a special shortcut. All right, what you were taught is midpoint equals adding the x's and getting an average. X1 plus x2 divided by 2. Same thing with y's. Add up the two y's and divide by 2. That's two separate problems, right? And you can do that, and it might be quicker than what I'm getting ready to show you. Label your x1, y1, x2, y2, plug them in, get your answer. And if you do that, that's great. However, I want to show you something you may not have seen. All right, turn off the line, go to my next line. This also has a function for midpoint. Just type in the word midpoint, and it tells you we have a function. Now, just like before, we need two sets of parentheses. First set, -6 and 1. Don't forget your comma. Close, then put your comma. Now your next open, that's going to be our L, -4 and 3. -4, comma 3. Close parentheses, close parentheses. By the way, you see that dot just appeared on the graph? There's our midpoint, but even though we don't have a line, that is the midpoint. And I can also label it. All right. If I click on check label, it just told me the answer. -5, comma 2. So I also want to show you something else so I can make it look better. I was trying to show one of the other teachers this the other day. I could put a table here and draw that line. So -6 and 1, those are our endpoints. And then we got -4 and 3. Okay. Now you see those two red dots that just appeared there? All right. And I can also draw the line by turning the line on. Oop, it didn't happen. Let's try it again. Oh, I hit it twice. There we go. See the line just appeared? Okay. And the endpoints are right there in my table. And you can see that that midpoint that we punched in for, that's clearly in the middle, isn't it? Okay. So anyway, that's something you may not have seen before. You don't have to go to all the trouble, the tables if you don't want. Matter of fact, you don't have to do this at all. That's completely up to you. But I just want to show you an alternative. It may be quicker or better for you. Because if you know the word midpoint, if you just remembered how to put it in there, just like we did for distance, it'll figure it out for you. All right, there it is right there. Just remember, you can count the point if you want, or just check the label and it'll tell you what it is. So does that make sense? All right, so coming back to hovercam, that is -5 and 2. Okay, one of the things I just dearly love, all these logic questions. Okay, no problem. All right, so are we in the logic section? Nope, we're still over there. All right, so these are our P's and Q's. So let's read. Let P represent the statement, Jack goes camping this weekend, P. Let Q represent the statement, Jack plays golf this weekend. There's my Q. Still don't know what I'm doing. Let's see, which symbolic notation represents the statement, if Jack goes camping this weekend, then he will not golf. Jack goes camping this weekend, he will not golf. Okay, so they threw the word not in there. You see that? So if Jack goes camping, that's the same as up here. That's a P. Then he will not golf. Jack plays golf, will not play golf. So that's a not Q. So it's a P, therefore not Q. P, not Q, right here. You see what we did there? Okay, no problem. They threw in one not. So they didn't straight up tell me what they did. They just wrote it down and expected me to notice it and figure it out. And by the way, if you're not sure, just look at your answers. You got a variety of answers in here. You got some with two knots. You got them backwards, reverse, forward. You got the and symbol in there. You got all kinds of stuff. But you just have to look and see what's changed. Okay? They gave me one knot, and that was it. Okay. Given triangle ABC, which of the following ratios is equivalent to cosine B? Okay, this is a lot of fun. These are the kind of problems I've seen people miss a lot because they don't know what to do. All right, first of all, they told us cosine B. So that's kind of important. However, I also notice I got a right triangle here. When we start talking trig, it should be a right triangle. But I also know that I have a side I don't know what to answer to. So the first thing I'm going to do is get that side. You know what I mean? A squared plus B squared equals C squared. I'm going to use Pythagorean. A squared plus B squared equals C squared. So that's 15 squared plus 36 squared equals X squared. I'm just going to change that because I'm getting ready to throw it in the calculator. You know what I'm saying? That's as much as I'm going to do. Now I'm going to go to Desmos. Am I moving too fast? Okay, so I'm going to throw this in Desmos. All right, let me turn that point off, go down to my next line. All right, 15 squared. Remember, I'm not doing anything I don't have to do if the calculator can do it for me, right? All right, 15 squared plus 36 squared. Oops, 36. Remember what I said, always double check your stuff. Sometimes I hit a button wrong. Go again. There we go. 36 squared, come back down, equals X. Now, I'm not using that C because C is not on here. I could put it on here, but it's just easier to use X. So 15 squared plus 36 squared equals X squared. All right, now it drew a line. Let me go find it. I might have to zoom out some. Okay, now notice it gave me 2. All right, notice they're exactly the same if you look at absolute value. I got negative 39, I got positive 39. The reason for that is these squares, that X squared, okay? That said, you know you can't have a negative distance. That's like saying you're negative 5 feet tall, and you know that doesn't work. Just use the positive, okay? It's 39, right? So that's not the answer, all right? But what that is the answer of is that's my hypotenuse. That's my C, right? So I'm coming back out to hovercam, all right? So I just filled that in. Now I got all 3 sides. Does that make sense? Okay, so we're looking for ratios, all right? If you look at your answers, we got these fractions here. So we're looking for cosine of B. Again, you got to know what that means. So if you don't forget, it's on your formula sheet, SOHCAHTOA. So I'm going to write it here again real quick. SOHCAHTOA. That's how I like to write it. They said cosine, right? Cosine of B. So that's 2 parts. Cosine means that that's going to be my part, this right here, okay? And cosine of B means the angle. So that means I'm looking at angle B. B is going to be my given angle. So when I look at cosine of B, that means I'm using my adjacent and my hypotenuse. You know about that, right? So my hypotenuse is here, slide across from the right angle. And my adjacent is not the opposite because that's opposite the angle next to it. That's my adjacent. So I got A over H, right? So if I'm going to write this correctly, cosine of B equals A, which is 36, over H, which is 39. Now, I don't see that down here, do I? I need to simplify it. Now, you can simplify it by hand like you learned in elementary school, or you could put it in Desmos. Watch this. You may not have seen this either. All right, so I'm going to get rid of this line. Let me get rid of this label. I forgot to turn all that stuff off. Turn off the line. Okay. So I got 36 over 39. And if I let the calculator calculate it, it gives me a decimal. That's not a ratio. That's not what we want. Over here, if you look, you got that box on top of a box with the divider line. If you click it, watch what happens. Oops, there we go. Notice that it turned that 36 and 39 to 12 over 13. Have you ever seen that before? You have? Okay, good. So you know how to simplify in the calculator. So our answer is 12 over 13. And if we come back to the hover cam, there it is right there. Not D, but C. 12 over 13. Did that make sense? That one took a little longer to do, but that's because we had to figure out a side. Okay, more trig stuff. I actually like trig. All right, so we got this roller coaster here. It said if the vertical height of the roller coaster below is 315 feet, find D to the nearest foot. Okay, now I'm not a big fan of these pictures like this. I can't see them very well, so I just draw a right triangle out to the side. It said I got 315 feet, meaning vertical straight up, so that means this is my 315. And I'm trying to find D, which is going to be the hypotenuse across from the right angle. So I'm going to put an X there, okay? That's why there's an X here. Oh, I'm sorry. Can you see it now? All right, so I redrew my triangle, all right? And it also gave me that 47 degrees in my right angle. So there's my right angle, there's my 47 degrees. So I'm trying to find a missing side, my hypotenuse. So again, I'm doing SOHCAHTOA. Okay. Now, I always start at my given angle. Is there anything across from it for opposite? No, there's no measurement or X here. So the next thing I'm looking at is my hypotenuse. There is an X there, so I put an H, and there is something next to it, so I put an A. So I got A and H. So again, A and H is cosine, right? So the cosine of 47 degrees equals A, which is 315, over H, which is X. You with me so far? And I can do that by hand, or I can move stuff around. I know you probably taught to switch something, or I'm just going to go put it in Desmos. So this time we get to use our functions. This was the cosine of 47 degrees. Notice it put our parentheses there for us. And that equals 315 divided by X. It drew us a line, so let's go find it. This one's going to be out there quite a bit. Let's see. I can't even click on this one. All right, so it's awfully close to 462. It said to the nearest foot. Would you agree that's closest to 462? So that's 462. All right. And that is one of my answer choices. So let's go back to the hover cam. 462 is right there, so that's our answer, B. You understand how I did that? Excellent. All right, diagonals of a square. Now, notice, look at all our answers. Our answers look crazy. Those are radicals, aren't they? Now, you might have been taught how to do this a certain way, but most people don't remember the special ways of doing this. That way, that said, it's still square, and square, well, let's just draw the square. Let's make it work. All right, so I'm gonna draw a square. All right. It said the diagonals of a square measure 24 meters. That means when I draw that whole thing is 24 meters long, right? And if I draw another one, that one is also 24 meters. But they also cut each other in half. Do you agree? So that means this side is 12, this side is 12, that's 12, that's 12. And don't forget that this also intersects at right angles, right? So guess what we did? We just created a right triangle. So I'm going to redraw that right triangle down here by itself. There's my right angle. Can you see my drawing out there okay? And this side is 12, and this side is 12. So not only is it a right triangle, it's also an isosceles right triangle. Do you understand? And they want me to find the length of the side, that base, if we turn it sideways right there. So that's an x. All right, so there's several ways we can do this. I'm gonna do the easiest one. Since this is a right triangle, just use Pythagorean. A squared plus b squared equals c squared, right? The one that you need to keep straight is your hypotenuse, because that is the one across from the right angle. That is our c squared, right? So that means 12 squared plus 12 squared equals x squared. A squared plus b squared equals c squared. Now, I could work that out by hand real fast, but most people may not be able to do that, and that's fine. Just throw it in Desmos. All right, 12 squared plus 12 squared equals x squared. Let the calculator do the work. Hit that home button to reset. All right, let's go. Oh, there's our line. We got a double line again. That's called that squared on the x, right? Remember, don't use the negative, use the positive. So that positive is 16.971. All right, now write it down, 16.971. Now let's go back to our answer sheet on HoverCam. Do you see that answer? No. That's okay. It's okay. It's just radicals. Let's throw each one of those radicals in the calculator until we find a match. You understand? All right, so let's go to Desmos. All right, and let's see. 8 square roots of 2. Is that 16.9? Nope. So let's do the next one. 10 square roots of 2. Is that 16? Nope, it's not it. Next one is 12 square roots of 2. 16.97, there it is. All right, now just to cover our bases, let's do 24 just to make sure. 24, not even close, is it? So that means 12. 12 square roots of 2 is our 16.97. See how we did that? So 12 square roots of 2, that is C. So there's your answer. Use Desmos, folks. Use your calculator. Oh, we got another one, and I marked that one up too early. That's okay, we'll make it work. Okay, so it says, given triangle LMN is similar, that sideways S is similar to QPR, find RQ. So we're looking for side RQ. Now, since they said this is similar, that means I need to know a ratio. And I don't think on yours, is it marked up like mine is? Okay, hopefully you can see that we have an 8 over here and a 12 over here. Can you see that? Okay, so I'm gonna make sure that these sides are similar. That's LM on the first 2 letters of the first triangle. So that better be the first 2 of the second, QP, and it is. So I'm just gonna put 8 over 12. Now, I can reduce that and get a ratio if I want, or I can just throw it in Desmos. That's what I'm always gonna do. Throw it in Desmos, simplify it. 8 divided by 12, hit the little button there, 2/3, that's my ratio. So my ratio is 2/3, and that's what I'm gonna use to solve this, okay? So let's go back to our HoverCam. So I got a ratio of 2/3, and I'm gonna turn this into a proportion. They want me to find RQ. RQ is this side right here. That's 2x plus 5, right? So I got 2x plus 5. RQ goes with, that's the first and last letter. First and last letter is L and N, so that means L and N is x plus 7. So there's my 2 comparisons. Now, since this is the smaller one, that's the 2 and this is the 3, you understand the ratio, 2 and 3? I need to make sure I put these in the same position. Since my 2 and 3 is on top down here, that means my x plus 7 better go on top here as well. Means my 2x plus 5 goes on the bottom with the 3. Now, I could crisp multiply and do that whole thing with a proportion, or I can just throw it in Desmos, which is what I'm going to do. All right, so 2 divided by 3 equals x plus 7. If you have trouble getting that whole thing underneath, all right, don't forget, just put that top section on the right inside parentheses, x plus 7 divided by 2x plus 5. See what I did there?
I can get it all on top.
Okay, since you saw what happened, as soon as I hit divide, it did something weird, right? It made it look funny. Just make sure you put everything on top in parentheses. That way it forced it when I hit divide to put everything else on the bottom. You understand? Good question, because some people get stuck there. Now, you can see that drew a line for me, right? And there's my line, just like we did before. And that line is on 11. So my x equals 11. So let's go back to hovercam. X equals 11. Now, I see that in my answer choices, right? But is that the question they're asking? No, that's why I circled it. We're finding RQ. RQ is 2x plus 5. So I need to plug that in. 2x plus 5. Now, I could throw that in the calculator, or you can do it by hand, whichever one's best or quickest for you. Since I know that's 11, I know that 2 times 11 is 22, plus 5, that's going to equal 27. See what I did there? Now, you can put that in the calculator, and I said I would for most of the things I would, or almost everything. But honestly, that one was so quick for me, I just did it by hand. Does that make sense? Okay, and is that one of my answers? Yes, it is. C. So even though you see an answer for 11, and 11 is correct for X, you're not answering the question. That's why I always make sure, double check, what is the question? Okay, oh, I marked this one up horribly. I am so sorry. Let me see if I have a different copy of this one. Matter of fact, do you have, actually, I have a whole bunch of them right here, but they're little. That was, where are we? Yeah, there we go. Maybe I can zoom in enough where you can see it, but you can see the one on yours, right? Okay, I'm sorry that this one's all messed up. Yeah, that's not helping much either, is it? Okay, maybe I can get us through this one. Sorry about this, folks. Let's see if you can see through the mess here. Okay, so this says which pair of triangles cannot be curved congruent. Okay, so the first thing I'm going to do is label everything, and I'll label in order. You can see this first pair of triangles. We got a side, we got an angle, we got a side. That's why I put SAS. You with me so far? All right, did the same thing on this triangle right there, SAS. So that's one thing. We'll come back to that. Next set. All right, I'm going in order again. I got a side S, angle A. I know they also have vertical angles, so that's SAA. Same other triangle as well, SAA. All right, or you can put AAS as long as you go in order in our whatever that word is I'm looking for. It'll come to me. Consistent. C, I got two triangles and they're sharing a side. Side, side, and that third side that they share with the reflexive property, they share that side too. So side, side, side. Now I got D, all right? I got a side, and they have a vertical angle. Side, side, angle. So we got ASS. So what I did over here real quick is write all those down. I got side, angle, side. I got angle, angle, side. I got side, side, side. And then I got SSA or ASS. All right. In any event, 3 of these will work. 1 of them will not. The easy way to know is this one's a potty mouth. All right. We know that, right? Now, that's not the reason we won't use it. All right. But this will not work every single time. That's where hypotenuse leg and some other things come into play. But we know that this one won't work. We know SAS, AAS, and side, side, side. All 3 of those will give us congruent triangles. But just remember, the easiest way is, even if it's SSA, that's backwards. It's still the same thing, right? Yeah. Keep it in alphabetical order. It's going to spell the naughty word. So in either event, that one won't work. So our answer, which cannot be proved congruent, is D. So even though that my problem was kind of messy because I scratched it up real bad, do you understand how we did that? Yeah. All right, excellent. Okay, I did that the same thing on here too. That's okay though. Which of the following side lengths could form a triangle? So you need to know how the side lengths in a triangle form, right? two shortest sides must be longer than the third. You know that, right? Two shortest sides added together must be longer than the longest side. Otherwise, you physically cannot form a triangle. You can cut out some sticks and prove it. So anyway, even though this is all marked up, folks, this is the way I do mine. The first thing I do is I'm going to circle or highlight my two shortest sides in each one of these. 3 and 8, 21 and 24, 10 and 11, 9 and 14, 32 and 35. Then I'm going to add them up real quick. 7 and 7 is 14. That's not bigger than 15. Can't be a triangle. 3 and 8 is 11. Shorter than 16. Can't be a triangle. 21 and 24 add up to 45. That's longer. That can be a triangle. 10 and 11 is 21. That's equal, but it's not bigger. Can't be a triangle. 9 and 14, that adds up to 23. That's bigger than 16. That's a triangle. 32, 35, that's 67. That's definitely a triangle. So hopefully you can see through the mess. This is a triangle, this is a triangle, and this is a triangle. You see what we did there? All right. Okay. This one, talking about triangles, what we don't have is the picture. Again, I marked this one up. Sorry about that, but we'll still walk through it. So the first thing I'm going to do, because I love pictures, triangle DEF, and it doesn't matter what it looks like, DEF. I'm just going to label stuff. DE is 29 feet, EF is 26 feet, and DF on the bottom is 32, which correctly gives the order of the angle measures from largest to smallest. Largest to smallest. What you need to remember is associated sides go with their angle, meaning the biggest angle is across from the longest side. Shortest angle, smallest angle is across from the shortest side. Okay, so since it said largest, I'm going to go find my largest side, 29, 26, 32. There's my largest, and I'm going to circle that to make it stand out. That's directly across from E. So angle E is my biggest angle. Do you agree? First thing I'm going to do now, see if I don't have to do any more work. What can I eliminate down here? E is not first here. Eliminate B. E is not first in C. It isn't here. It is first in D. So far I'm down to A and D. My medium angle, 29, 26. All right, I'm going to put a box around that one. That's across from angle F. So angle F is my middle angle. And F is the second angle in A. It is not in D, so I can eliminate D. And I'm done. And by the way, angle D is my shortest or smallest angle, and that is across from the smallest side. See how we did that? All right, we are done. By the way, I'm gonna take a short little break. We have made great time. We got almost 25 minutes, and we are cranking these problems out. Do you feel like you're learning stuff out of this?
Yeah.
Okay, I need to stretch my legs for a second. Okay. All right. Triangle stuff. Love triangles. All right. A triathlon event in which participants run, bike, and swim certain distances is mapped out in the triangle below. Okay, so which statement is true? Now, I know I marked mine up, but the first thing I saw when I looked at this problem was I got two angles and I don't have the third, but I can get that real easy, right? So what I did was 180, because all triangles add up to 180, subtract 57 and 65 from that, and you can throw that in Desmos, right? And when I'm done, 180 minus 57 minus 65 is going to give me a 58. So I got 58 degrees here. Now, we got all three angles. So some people don't know how to do these, but that's okay. Remember, shortest sides, longest sides go with the biggest angle, shortest sides go with the smallest angle, right? So I'm going to label these longest, medium, and smallest, or shortest, I mean. So I'm going to find my biggest angle, 65 degrees. That's across from my largest side, so I'm going to put an L there. My middle angle is 58. across from the bike. So I'm gonna put an M there for medium. And then I'm gonna put 57 is my smallest angle across from my shortest side. Okay, you with me so far? All right, and let's just see which statement is true. The run distance is greater than the swim distance. Well, let's see if that's true. Run is small. Small can't be bigger than anything, can it? So it can't be A. B says bike distance is less than run distance. Well, bike distance is medium. Medium can't be less than small, so it's not B. C says the swim distance is less than, and I'm gonna stop right there. My swim is my longest side, right? It can't be less than anything, so it can't be C, which leaves us with D. The bike distance is greater than the run distance. Medium is bigger than small. That is true. See how we did that? All right. Yeah, I must have accidentally saved all these on my PowerPoint. Okay, that's okay though. Back to logic stuff. Given the statements below, which is a valid conclusion? Okay, no problem. If it is Tuesday, that sounds like a P. Then Luke has math club. That sounds like a Q. If Luke has math club, that sounds real similar to that one, doesn't it? So that's a Q again. Then he will take the late bus. That's something new. P, Q, Q. That sounds like an R. So that means this is a cut out the middleman problem. You know what I'm talking about? So if Q repeats, that means if P, then R. Do you remember that? If P, then Q. If Q, then R. Cut out the middleman, the Q's, and go straight from if P, then R. So P, then R. All right, so which one is a valid conclusion? If it is not Tuesday, oh, they threw that word not in there, then Luke does not have math club. Okay, now there is a not here, but they left the Q in there. That is not if P, then R. So that doesn't work necessarily. All right, if, let's see, if it is Tuesday, then Luke will take the late bus. If P, then R. That's our P, then R. That's going to be our correct answer. But let's finish eliminating. If Luke takes the late bus, that is, they just skipped straight to Q. If Q, then it is Tuesday. If Q, then P. That's not what we're doing at all, is it? That doesn't work that way. It doesn't necessarily have to be there. If Luke does not have math club, then he will not take the late bus. Again, that's not our P, then R. So there's our answer right there. Does that make sense? I know some people get stuck in these P's and R's and P's and Q's, but just label stuff. Just try to label and match it up. Okay, I marked this one up too. Statement X. If two circles are congruent, that's going to be our P, then their diameters are congruent. That's our Q. Statement Y. If the diameters of two circles are congruent, then the circles are congruent. I had to think about that one for a minute because they reworded some things, but that's okay. All right, so the Q up here was, then their diameters are congruent. So right here, they did say if the diameters of two circles are congruent. So that's our Q. Then they put here, then the circles are congruent. That's our P from up top, if circles are congruent. So they just reversed them, didn't they? So instead of if P, then Q, that's if Q, then P. Hello.
You want something?
Sure.
You want something? It doesn't matter if you want something more. You're gonna get Chick-fil-A at the end.
Oh, I'm looking forward to that.
So just take whatever you want, and I'm gonna go down the hall.
By the way, just so you know, I'm recording mine, so I'm gonna make it available.
No problem. Do you want anything?
I'll take a bottle of water, sure. Thank you. All right, P's and Q's. That's not everybody's favorite, but if you label them and step through them, reread them, match things up, it'll be okay, right? All right, any questions about that one? All right, next. I marked this one up too, and that's okay. All right, statement A. If it rains, that's a P, then the softball game will be canceled. That's a Q. Statement B. If it does not rain, that sounds just like our P, except they threw in not, so not P. Then the softball game will not be canceled. That's just like Q, except they threw in not. So P then Q, then not P, not Q. Okay, so statement B is inverse, converse, contrapositive, biconditional. All right, first of all, they didn't switch Q and P, so it's not a converse. It's not biconditional because they didn't say if and only if. It's not a contrapositive because they didn't reverse P and Q, but they did put nots in there. So since they only put nots in there, it's an inverse, right? P then Q, not P, not Q. You throw in the knots. So our answer, A. All right. Oh, wonderful. More logic. Okay. Let P represent Mary works at the water park. Okay, that's P. Let Q represent Mary takes college classes. Okay, no problem. Which symbolic notation represents the statement Mary works at the water park or takes college classes? As soon as I saw that word or, I remembered I got these two symbols. The one that looks like this, like a caret, that's like an A. The one that's like a V, that's my or. So that's and that's or. As soon as I saw or, I'm looking for this symbol. The only one that has that symbol is A. P or Q. See what we did there? P and Q doesn't work. P then Q doesn't work. If and only if, that isn't there either. So it's A. I didn't even have to think about that one at all. I just saw the word or, right? And oh my gosh, is that all of them? We did it. We got through all of them. How many questions was that?
Can we go back over the congruent triangles?
Congruent triangles? What numbers? I know that they repeat numbers, but what number is that on there? Congruent triangles. So we got a number 9 in here somewhere. Congruent triangles. Okay. Congruent. Is it congruent or similar triangles?
It says which pair of triangles cannot include.
Oh, gotcha. The one I messed up really bad. All right, so I may have to redraw these because I just completely destroyed mine. All right, so what is your question?
I was just wondering how you got to the answer.
Okay. All right, so can you see through the lines that I drew on here? All right, so let me just start with my process again real slow, okay? Because we got time. I'm glad you asked. So I looked at A. I'm covering up all the mess here. And I'm looking at my congruency marks. I see one tick, one tick. I see one arc, and I see two ticks, two ticks. That's SAS. Either way I go in order, it's SAS, okay? So I just wrote that down. I know that's one of my valid ways I can prove triangles congruent, right? Side, angle, side. I know that. And that's something you'll have to know. All right, then I went to B. All right, same thing. I got one tick mark on the side. I got a congruent mark for an angle. They didn't mark the angles in the middle, but I know those are congruent because they're vertical, right? So SAA or AAS. Either way it works, as long as you stay in order. You understand so far? All right, then we go to C. C is probably the easiest. One mark, two marks, but they share a side, so that side is congruent to itself. So that's side, 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 right? Side, 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 no matter which way you go. So I wrote that down too, all right? Now, the last one, okay, this is one people get wrong all the time. All right, we got one congruency mark, two congruency marks, and those are both sides. Then we got a set of vertical angles here in the middle. So those are congruent. And that's either SSA or ASS. You have to go in order, right? You can't skip around. Now, the easy way to remember that this one doesn't work is because it spells a naughty word, okay? That should make it easy for everybody. There is an explanation. This won't work every time, okay? It won't work every time. And the reason for that is when we have a right triangle, we got the hypotenuse leg, which, by the way, is also similar to SSA, but instead of calling it SSA, it's hypotenuse leg. but that's because it has a right angle, and that makes it orient correctly, and that does work every time. ASS will not work every time. Now, it might work, but it won't work every time. In order for these to work every time, sorry, in order for these to prove triangles congruent, they have to work every time. Okay, that's the difference. But if you can't remember the big explanation part of it, just remember, don't be using no naughty words, right? Even if it's backwards, but that's why I say put it in alphabetical order, because you'll see that, right? And hopefully, I mean, this one didn't give us the reverse of that, which one of these will prove or not prove. And remember, this one, by the way, said cannot prove, so make sure you highlight that. But just remember, the one that spells the word like that can't be used. Okay? All right, did you have any questions about any other ones? All right, now I realize that was a blitzkrieg going through a bunch of geometry problems. I feel like that was 40-something problems. Matter of fact, on my PowerPoint, how many slides was it? 46, and that means, oh, wait, 46 slides divided by 2, because each one of those had an answer. So that wasn't 40 problems, that was 23 problems. That wasn't so bad. But those are problems that people tend to have a lot of trouble with. And those are definitely on the SOL. You're going to see a variety of those in some form or fashion. So I have recorded this, and I'm going to make it available to whoever wants to see it. And I'm going to send the link to Mrs. Holmes. And since she's your teacher, she can share that link with you. Okay? So unless there's anything else you want me to go over, that's all I had planned. Okay? So let me go ahead and minimize this and this. And also remember that Desmos calculator. I think you learned a few things about at least the midpoint and distances in here if you want to do it that way. Yeah. Lots of things. I'm going to keep pushing it. Use that Desmos. And other than that, I'm going to go ahead and stop the recording. And as soon as that generates the meeting link, I'll send it to Ms. Holmes or whoever, and they can share it. People can look at that